Hi, welcome to episode 4 of Cainers Commodore Cakers. It's been a while since I did my last one. Things have been unbelievably busy. However, what I have managed to do is get myself a box of broken Commodore 64 breadbin boards, and there's a couple of 128 boards thrown in there, I believe. They look like this, as you can see, classic Commodore boards. Various different types, various different problems. They're all missing SIDs apparently, so who knows, we'll have a look and see what's going on. There won't be too much technical stuff. It'll literally be a case of turn it on, find out what's going on. I can then pinpoint and perhaps have a look. Having seen most faults before, we don't need to diagnose too much. We can bam bam bam. I'm sure there's one or two that's going to take me to church, but first of all, let's get unboxing these boards. Got the first board set up here. You can see this one's missing the SID. Obviously I've got my anti-static mat here, and I've got this sat on top of a bit of cardboard just in case there's any problems. But let's power this bad boy up and see what happens. Okay, there you can see we've got a classic memory issue there. You can see there we've got out of memory error in 0, and that's what you get when the 64 tries to power up, does its memory check, and then hits something it can't read or write to. You'll also see on the screen here that we've got the occasional glitch, which indicates that there is a problem with the memory. Now the rest, the initialization circuits and the actual memory mapping is working properly because we've got a blue background, we've got a border, we haven't got too many random characters on the screen, but these little characters here, flashing on and off, indicate there's an error with the memory module. Now what we can do with this, which is quite fortunate, we can occasionally use a piggybacking technique which will allow us to ascertain exactly which chips are faulty, and I'll show you how we do that now. Okay, so I'm just going to try piggybacking this chip here. Okay, now you can see that's made a difference. We've still got the out of memory error, but you can see that's made a difference, and the screen is clear. So I think what I'll do first of all is we'll swap that chip out. I'll desolder it. I'm not going to video that because you've seen me do that lots of times before. We'll desolder that, socket it, and then give it a try afterwards. Right, there we are. Here's our soldered 4164. Let's power it up and see if that's made a difference. And there we are. Just the one chip, just the one dodgy RAM chip, stopping the whole system from powering up. And as you can see what I did there, I piggybacked the chip, got rid of those squares on the screen. As soon as that made a difference to the output, changed that chip, and away we go. I'm going to put a SID in this and give it a test, and we'll go from there, see what we can do. Here we have board number 2. Now I powered this one up earlier and didn't seem to have a problem with it. I've just put a SID in it, and I've hooked up my cartridge and my lead just to make sure what's going on. So we'll power it up. Okay, and there we've got the action replay. Now what's happening is, which does seem a bit strange, is if I hit F1 to configure memory, it freezes. You can see there's a lot of rubbish on the screen there, so I'm going to turn it off. Turn it back on again. And if I do a normal reset, that also freezes. So something's not quite right there. I've also tried loading a demo, and everything appeared to be okay. It got stuck on the blue screen whilst loading. So what I'm going to do is we're going to hook up, because this isn't a particularly easy one, we're going to hook up my test rig, and we'll have a look and see if we can pick up any errors from that. Here we are set up with the Commodore, with the test rig. We've got the keyboard connector tester, the user port connector tester, the cassette tester, serial tester, and we've got the 2 joystick ports here. Now what I found when I connected all these up is that it didn't power up. So try that. Completely black screen. So turn it off, just remove the cassette connector. Powers up, does the test. Now this test takes a while to run, But what it's shown me is it seems to think that the both the 6256's U1 and U2 are bad. Now the one that's responsible for reading from the cassette port is this one, which is U1, which also does the keyboard port. I just think it's a bit strange that reading from the cassette port there's an issue. It stops the machine from coming up. So just to check, what we're going to do is I will desolder U1, which is that 6526 there. We'll desolder U1, swap it out just to see if it makes any difference. Socketed the 6526 chip here, which you may or may not be able to see. Here's the old one. Let's see if it powers up with the tape connector in it. No, okay, so we've still got a problem there. The only other two things that can be, or what the diagnostic cartridge is telling me is, we're still getting an interrupt problem, and it's still telling me that both of these are bad. Also, the cassette port connects right onto the 6510. So we'll whip that out, swap those around, see where we go from there. I've hooked up the 1541. I've also reinstalled the two original 6526s, and we've got the new processor installed there. Okay. Fantastic. Let's see if we can do a configure memory. Brilliant. See if we can do a normal reset, which wouldn't work previously. Brilliant. Okay, I'm going to install fast load. I'm going to go down to demos. I'm going to mount goat light. Brilliant, that's a bit more like it. Previously it just hung on this blue screen. And there you go. Another breadbin more rescued. Let's crack on with the next one. Board number 3. Let's power it up, see what happens. Nothing at all, completely black. Okay, I think it's time to get my scope out, have a little nosy, see if we can find out what's going on. We're going to have a look at the data bus by looking at pin 2 on the RAM. Because there we go. So you can see there's a little bit of activity. All looks okay though, don't appear any dead ones. Okay, just switch that off, turn it on again. Okay, that's all pretty normal, but it is actually quite static. It doesn't appear to be doing anything, so it's going round and round in circles. I'm just going to check the chip select on the kernel ROM, because obviously it needs to be kicked in. Ew. Now that isn't healthy. That should be changing. That should be at least up here. It should be 5 volts. You can see it's just cycling between 1 volt there. That's not going to help at all. That's not going to kick anything in. That chip select comes directly from the PLA, so we could have here a faulty PLA. We'll whip that bad boy out and swap it over and give it a go. Okay, we've replaced the PLA. Have a look at what that's doing. Brilliant. As you can see now, it's a lot better. But check out the display. Look what we've got. Okay, so we've got some duff RAM chips in there. So again, it's the out of memory error. So we'll try replacing or piggybacking the RAM. See if we can fix that. Right, we've replaced the two 4164s and we've replaced the PLA. Here's the duff chips we've replaced. Let's see what happens. And there you have it, 38911. Fantastic, all good. Right, next board. As you can see, this one has no SID. It's got no SID there. It also has no. It's also missing a VIC. So the first thing we'll do, I've got a VIC here. We'll stick a VIC in. Just push that in there. Okay, let's power that up. Okay, so nothing at all. So as you can see there, we've still got, it's just saying no signal, nothing at all coming out of it. Now, that's normally a power issue, or alternatively it can mean that the systems are getting no clock. So I'm just going to measure the power here. I'll measure the 12 and the 5. I'm going to measure the 12 off the regulator. As you can see, we've got 12.6 there, so no problems with that. I'm going to measure 5 off of this regulator, 5.6 there, no worries. I'm also going to measure 5 off of the RAM. Got 5.094 there as well. So that's all cool. Next thing we'll do, we'll have a quick look with the scope, just to see if there's any clock being provided to the 6510. Pin 1 on the 6510. Okay, so there's no clock being provided. It's literally just, there's nothing there at all. You've got no clock, nothing at all. So on these, with this particular model, the 8701, which is this chip here, does all the clock dividing. The actual clock is generated by this crystal here. The 8701 gets rid of a lot of the discrete logic that used to be around here. So we'll swap that bad boy out. Making sure that we put it in the right way. Let's have a look what we get. Hey, another out of memory error. Okay, so we've got another problem with the RAM here, which we'll look at. Now, I don't know if you've noticed, but these particular RAMs, these MT264s, they've been the ones that we've had the most problems with. Each board that's had a failure has had this particular RAM in it. So now we've got life, we've got clock, and we've got another memory fault. So I'm going to do some more piggybacking, and we'll see if we can find out which one's causing it. Okay, you know it's been replaced. I've also put back the original 4164 that didn't seem to make any difference when I changed it earlier. So I'm now going to power it up and we'll have a look. And there we are, another one arisen from the dead. 8701 8569. I'm going to put a SID in this and we'll give it a test. Also with the 4164 replaced. So all so far pretty easy fixes. Okay, next board. Again, you can see this one is missing the SID. I've whipped the top off to check the VIX there. Now, it does appear to power up, however, the characters on the screen are all jumbled. Ew, not pretty. Now, I think personally, and I've seen this before, that looks like the multiplexers, that looks like it's a RAM multiplexers, this one and this one, because of the way that the display is assembled. It looks like it's not addressing the right parts of RAM, so all the addressing is wrong, which is what the multiplexers do. Possibly kernel, possibly basic, could be the VIC, but or alternatively, what I also have seen is it's the 6526s as well. So we can try either of these two. We can also give these the multiplexers a try. I'll try the VIC as it's socketed because we've got a spare and it's nice and easy to do. So we'll give that one a try. I'll do that now. Grab us a VIC. 99.9% sure it's not going to be the VIC, but we'll give it a spin. Okay, let's try it. Spin it up. No, exactly the same problem. So I didn't think it'd be the VIC. So what we'll do is I'll try the multiplexers first of all, and then we'll go for the 6526s. It's likely to be RAM banking, bank switching, which the 6526s are responsible for. The fact that there's no flashing cursor could also lead me to the 6526. So I think I might try those first. We'll give them a spin, and then maybe the multiplexers afterwards. But I'll be back in a sec when I've swapped out the 6526s. There's the two 6526s replaced. Let's power up, see if that's helped. No, still the same. So we'll go for the RAM multiplexers, which are the 257s here. Give that a spin. Okay, so we've changed the 6526s and the 257s, which is my hunch as to what it is. Not necessarily exactly what it is, but it's my hunch. Let's have a look and see if it powers up. Okay, so we've got the same problem. Something very strange going on there. I think I'm going to go and have to get my have a little look at the circuit diagram, see if we can figure out what's going on. It's obviously something to do with the way that memory is being mapped to the video chip or the screen memory, or something's being mapped incorrectly. I'm going to go and have a little look, and I'll be back in a sec. Having looked at the 64 video circuitry and what the VIC uses to interrogate and grab hold of the RAM, I've had a look at. I've changed this to 373. I've also changed the 4066, which are two possible candidates. But having looked a little bit better, I noticed the 74LS258 was an actual fact. You can see that there. Should come into focus in a second. A MOS 7709. Now these MOS ones, especially if they're sat in the LS257s, are notorious for falling on their backside, notorious for falling over. So I thought, having had a quick look at it, and it actually addresses A6 and A7. It's what the VIC, I'm not quite sure how it does it, but basically the VIC relies on this for its A6 and A7 access, and we could see from what was coming up on the screen as an addressing error. So if I now switch this on, there we go, up and running once again. I'm going to stick the diode cartridge in and run another demo. We'll go from there.